So how would you do the first warm-up today? Divide by what? 3. Good. When you divide both sides by 3, you get that x equals 9. Good. What do you do on the next one? Subtract 6. Yep. So you end up with x, because those cancel, equals -23. Good. All right. Number 3. Add 9. Add 9. So x equals 29. Okay, the next one's kind of tricky. You got to divide by 2/3. Now, dividing by 2/3 is the same thing as multiplying by what? Do you remember how you divide fractions? You actually do what? You multiply them and you flip the second number. So we're actually multiplying by 3/2. Alright, so those are going to, that actually gives you 6/6x, which is 1x, that's what we're after, equals, when you multiply across the top you get 18, across the bottom you get 2. What's 18/2? 9, very good. Yeah, that one is actually a lot easier with a calculator because you could keep it as division. The calculator knows that it has to flip and multiply. But if you're doing it by hand, you got to flip it and multiply. That's the only way. All right, and then problem 5. That is like a -1x. You want to divide by -1 on both sides, so you get -4 as your solution. Good. What are your questions? Is your notes are long? Yes, very long. All right, I will come around to get your warm-ups. Make sure your names are on them. And here is what we're doing today. All right, so today we're doing the last section in Chapter 2. It is Section 2.6. It's all about the properties of equality and congruency. We are actually only going to write in our notes the properties of equality, but they will all still apply with congruency. So the congruency ones will be on the board, but we're just going to write down the equality ones. The only difference is the equality ones have an equal sign. The congruency ones have the congruency symbol. All right, so they're the exact same thing. So if you're wondering why I'm only making you write half of every slide, that's basically because the only difference is the symbol. So know that these properties work for both symbols when they're equal and when they're congruent. Now, our objective today is to use properties of equality and congruence. So it's a lot like yesterday where I'm just going to give you a bunch of laws, a bunch of properties, and then we're going to apply it to the problems that come up next. Any questions? Alright, quick reminder, you might also want to check this out. I said it earlier, I'll say it again. These are the sections you need on Friday. So, if I was you, between now and Friday, flip through your notes. Make sure you have all 6 of those sections with the number, with the title, and with the objective. If you're missing any, you can get them from a friend. You can ask Miss Roberg tomorrow if she'll give you a copy. Maybe if you're really nice, she will. Or you can watch them on YouTube. Any questions about this looming notebook quiz? All right, let's get going with today's notes then. Here's the first property. This is a property of equality and congruence. You can tell it's equality when it has an equal side. It's congruence when it has a congruence symbol, congruency symbol in there. So I want you to just write part A. So you're going to write this. This is the reflexive property. And then this is the reflexive property right here. Okay, and then you should know that this works for equality and congruence. If you want to put those two words in your notebook by reflexive property, you can, or you can just remember that equal signs and congruency symbols both hold true for these properties. Now, I'm going to write them over on the board. You can see them up here. Can you guys read these? The green ones are kind of hard to see. I'll rewrite them. But it's nice to have a place where you can refer back to all of these, so I would try to write them all really close to each other in your notes so that you can flip right to that page and then try to distinguish which property we're talking about for that particular example. Here's the next one. This is the symmetric property. Again, this works for equality and congruence. Make sure you have this title, that this is the symmetric property, and then just this would be enough for me. Again, just remember in your head that it works for both equality and congruence. You don't need to write them both down. They're basically the same thing. But what is happening here is they're changing the order that they give you the information as being equal. So A, B equals CD is the same exact thing as CD equals AB. So it's symmetric. They're just flipping the order. We do this all the time when we solve equations, like if you got 3 equals x, and then you wrote it as x equals 3, it's the same thing. You probably never knew why. Here's the reason why. It's the symmetric property. The transitive property is a lot like what we talked about yesterday, the law of syllogism, where you can cut out the middleman. So you need to have in your notes the transitive property. And then what's in this box? So again, you can cut out the middleman. If AB equals CD and CD equals EF, then you go straight from the beginning to the end, AB equals EF. And again, this is called the transitive property, and it works if you're talking about congruent line segments as well, or congruent angles. Alright, here are some examples. I don't think it's necessary to write the directions on this, so if you want to just put 1A, then write out what you see, B, write out what you see, C, write out what you see. You will know that we were naming the property once we write the answers, so if you want to skip the directions, that's fine by me. There is one of each property on the board. There's 3 properties. There's 3 parts to this question. Does anyone think they definitely know one of them? You don't know how to do it? We are seeing which property it appears to be. So, for example, C is probably the easiest one. Which property has the exact same thing on both sides? Like looking in a mirror. So is that reflexive, symmetric, or transitive? Transitive is where you cut out the middleman. We didn't cut anybody out on part C. Reflexive. So this is the reflexive property. Again, I just started with C because I thought it was the easiest. So reflexive's out. There's only one for each. Which one are they cutting out somebody? A or B? A. So that's the transitive. And then you can see in part B, you had FG first equal to HJ. And then HJ equals to FG. So all they did was switch the order that they gave it to you. That's symmetric. So you're just seeing which property appears to be happening in these examples. And again, we kind of skipped over A. I'll explain it a little more. You can see that they had ST equal to UV, or sorry, congruent. Line segment ST is congruent to line segment UV. Line segment UV is congruent to line segment YZ. Then you can start from the beginning and go to the very end and say that ST is congruent to line segment YZ. You're just cutting out that UV, cutting out the middle guy. What questions do you guys have on this? All right, here is example 2. I am actually going to change the symbol a little bit just to take a step out for us. Make it look like that. So we are given this diagram. I would like you to draw the diagram. I would like you to write out the entire question. And then we are going to do what's called a 2-column proof. You have never seen these before. They are a little challenging. But you need what's written in words, the diagram, and then like a little T-chart off to the side or below your diagram. Yep. And then we're going to fill it in.
Like the T-chart?
Yeah, it's actually a 2-column proof, so you're basically just writing 2 columns. Make it kind of big. You're going to be writing in it. If you want to wait and see what we're writing in it and then draw it, that'd be fine too. Alright, so the whole idea of a 2-column proof is to tell me what you know over here and then tell me how you know it over here. So this is what you know, this is how you know it. Okay? So, one of the things we know is that AB is congruent to BC. How did I know that? It was given to me in the problem. So that's the first thing we know. Then I am told that line segment BC is congruent to line segment CD. How did I know that? It was also given to me in the problem. Now, I am trying to prove that AB is congruent to CD. Now, sometimes you'll have extra steps. You can't go straight from what they gave you to the end. You got to prove some stuff in the middle. But I learned a property today that tells me if I know a line segment AB is congruent to line segment BC, and I know that line segment BC is congruent to line segment CD, I can cut out the middleman. I can cut out the BCs and just say that AB is the same as CD. Which property tells me that? Who's cutting out the middleman? Which property? The 3 properties are listed on the board. Properties. You're not giving me segment lengths or anything. The properties. So your answers would be reflexive, symmetric, or transitive. Reflexive is when the exact same thing is on both sides of the equal sign. Transitive. Transitive is where you're cutting out the middleman. So that is your first 2-column proof, and you are done. So again, you start with what they gave you. This is what I know. This is how I know it. Then you follow what should be a logical set of arguments until you get to the end where you tell us what you are trying to show. Sometimes it only takes a few steps, like in this one. Sometimes it'll take a whole bunch more, okay? But again, what you know, how you know it. Now, you guys are pretty lucky in this class. I don't make you do 2-column proofs out of thin air. I usually give you something where it's mostly already written out and you're just filling in a few blanks. So again, this isn't something you'll need to know completely independently. I'll give you some guidance along the way. Any questions, though, on your first 2-column proof? All right, here's our next 2-column proof. So write what they give you. Draw the diagram. And then set up some room for our proof. So again, we need a big T. Left side is what we know. Right side is, well, how do we know it? All right, I want to do this one this way. I'm going to give you guys the left side. You're going to tell me the right side. Okay, so I'm going to tell you what we know. You're going to tell how we know it. So N is the midpoint of MP. How do I know that? It was given. So your reason is given. I also know that P is the midpoint of NQ. How do I know that? It was given. Good. All right, the next thing I want to say is that MN equals NP and that NP equals PQ. How do I know that? How do I know that all those things are congruent or equal to each other? How do I know that these two are equal? How do I know that these two are equal? Look at what we were given. Sometimes it's a property, sometimes it's a definition. What is N? What is P? One of the midpoints. Good. What does a midpoint give us? Two congruent line segments, right? So I know that MN is congruent to NP and NP is congruent to PQ because they're midpoints. Okay, so the reason is that that's the definition of a midpoint. Alright, I'm sort of out of space, so I'm going to write the last line actually up here on top so you guys can see it. I am now ready to say, well, MN equals PQ. How do I know that part? So all I did basically was cut out the middleman. I cut out the NP. That's the transitive property. Good. Great. So again, if you're like, how could I have ever come up with this on my own? You don't have to, all right? At least not in this class. All you have to do is sort of fill in the gaps that I leave for you. So again, we were given that N was the midpoint. We were given that P is the midpoint. I know that midpoints create congruent line segments. And then I know that congruent line segments, if you have two line segments congruent to the same line segment, then they're congruent to each other. That's the transitive property. Any questions? All right, we got a couple more properties to talk about when you guys are ready. Okay, I want you to write both of these down. I'll give you some time. Alright, if you're still writing, that's fine. I'm going to start explaining these, though. I think these are pretty simple. We use these all the time. We don't even really talk about it. But the addition property of equality, so when you see this in your homework, it'll say addition property of equality. These are all properties of equality. It basically says when you're adding the same number to each side of an equation, you'll produce an equivalent equation. So there was one in our warm-up where I don't remember what we added to both sides, 9 or something. We added 9 sides to both sides of the equal sign. The equation was still equal. Okay? That's the addition property of equality. Now, it works for subtraction too, right? There was one where we subtracted, I don't remember, 6 maybe, subtracted 6 from both sides. It was still an equivalent equation because we subtracted the same thing from both sides. Okay? Now, there are 2 more properties. I'm not going to make you write them down. Can you take a wild guess what they are? The division property. It states if you divide both sides by the same number, they're still equal. And then, yes, the multiplication property. So it works for all 4 operations. Again, I'm not going to make you write all of them. I think once you see that it works for 2, you can probably assume that it's going to work for all of them. But just so you know, those are coming up next. Any questions on these? Alright, so again, you don't need to write these down. There is one thing you might want to note. The multiplication property and the division property do not work if you multiply or divide by 0. So you see how it says a non-zero number? That's just something to take note of. Don't ever multiply both sides by 0 or divide both sides by 0. Alright, there is still one more property that I would like you to take a second to write down. That is the substitution property. Again, substitution property of equality. It says that substituting a number for a variable in an equation produces an equivalent equation. So if I tell you that x equals 3, you can take the x out, you can put the 3 in. That's the substitution property. Again, this is something we use often. We don't even realize we're doing it, but now you have a name to put with it. Here is our last example. I am actually going to say that you don't need to write this one down. You can just watch, okay? I do want to get your homework done together, but I do also want you to see this, so you don't need to write it. Just enjoy the show, okay? So we are given that angle 1 and angle 2 are both complementary to angle 3. We're trying to show that angle 1 is congruent to angle 2. So here is our 2-column proof. So what are we given? Angle 1 and angle 2 are both complementary to angle 3, given. Being complementary means what? Complementary angles add to what? Good, so I can say that angle 1 plus angle 3 equals 90, right? And angle 2 plus angle 3 also equals 90. Everybody see that? And that is the definition of complementary. Now, this next part's going to be tricky. This equals 90. So does this. So what can I say that they equal? I want to take the 90 out. I want to eliminate the middleman. So what can I say? Angle 1 plus angle 3 equals what? Take the 90 out. What are you left with? Angle 2 plus angle 3, right? Just eliminating the middleman, eliminating that 90. Everybody see that? What property is that? The transitive. Good. Now, what can I subtract from both sides? What do they both have? They both have an angle 3, right? So if I subtract the angle 3 from both sides, I am left with exactly what I'm trying to show. Everybody see that? Okay, so that is by subtraction. And we're done. Once you get to the line that looks like what you're trying to show, you are good. Now, technically, you shouldn't just replace an equal sign with a congruent sign, but I'm, like I said, not going to be too picky about that. You should technically write now that line, or that angle 1 is congruent to angle 2. That's the definition of congruence, but I'm fine if you want to stop there. Any questions? All right, here comes your homework. So, just like yesterday, we're going to work to the bell. Hope we get done. And also, just like yesterday, we are just going to focus on the evens. Now, 1 through 6 is matching. Sometimes for matching, it's actually easier to do them all. So if you feel like you want to do them all, that's fine. Notice like reflexive is on there twice, symmetric is on there twice, transitive is on there twice. The only difference is equality or congruence. So if you see equal signs, you should use the one that says equality. If you see congruent symbols, you should use the one that says congruence. Alright, so we're only doing even. So number 2. If line segment PQ is congruent to line segment RS, then line segment RS is congruent to line segment PQ. So we're talking about congruence, so it's one of the bottom 3. And all they did was switch the order. Reflexive is when it's exactly the same. It's not exactly the same. It's E. Yes, this is symmetric. And again, since it's congruency symbols, use the one that says congruence. Skip 3. It looks like on number 4, we're again just talking about congruence, so we're looking at D, E, and F. And it looks like they cut out the middleman. Transitive, good, of congruence, so that's F. You can skip number 5. Number 6 says that the measure of angle 3 is equal to, so now we're up in those equality. So the measure of angle 3 is equal to the measure of angle 4. Then the measure of angle 4 is congruent to the, or is equal to the measure of angle 3. So they just switched the order. So kind of like E, except now we're doing equality. So which one is it? B. Very good. Alright, skip 7. Number 8, we're saying which property is shown. So if LM is equal to NP, then 2 times ln is equal to 2 times np. So what did they do to both sides? What did they do? They multiplied. So this is the multiplication property of equality. Alright, number 10, what they do to both sides? Divide. So this is the division property of equality. Alright, and then number 12 is a proof. Now, they don't put the little t in there. I like it, so if I was you, I would add it. But it says in the diagram, AB plus BC equals 12 and BC equals 3. So those are both the things that are given, right? You can see they write out exactly what I just said, followed by the word given, exactly what I just said, followed by the word given. Now, we are trying to fill in the 2 blanks. So basically, how do they know this? How do they know that AB plus 3 equals 12? They took the BC out and they put the 3 in. So what'd they do? They replaced it. What is replacing called in math? Substitution. Good. This is the substitution property of equality. It's the last one you wrote down. Now this one's a little trickier. What did they do between the second to last line and the last line? Like, how did they go from 12 to 9? How did they go from AB plus 3 to AB? What did they do to both sides?
Divide. Right?
I don't think they divided. They subtracted what? Yeah, all they did was subtract 3 from both sides of the equal sign, or both sides of the equation. So this is the subtraction property of equality. Man, we are flying through this worksheet. One more to go. Questions so far? The question was, when is the upcoming test? Tuesday.
Oh, it is?
Over all of Chapter 2 will be Tuesday. We're reviewing what we learned this week tomorrow. Then the notebook quiz is all we're doing Friday, so you could review in class a little Friday. We'll do a whole chapter review Monday, and then the chapter test on Tuesday. All right, raise your hand if you need more time with this, because once I scroll down, these are all going to go away. All right. Number 14. Identify the property that is illustrated. So doing it with pictures, it's kind of hard to see, but this is a quarter, a nickel, and a dime equals a quarter, a nickel, and a dime. So it's the exact same thing. What's the exact same thing on both sides of the equal sign? Reflective. Good. Now, if you wanted to say reflective property of addition, you can, but again, I'm not too picky whether it's addition or congruence. Now, if you are someone who loves extra practice, you can go ahead and hold on to this and do the odds. If you're someone who's just looking for quick homework points, put your name on it and put it in the bin.